Okay, hello everyone. In this lecture series, we are discussing core paper 4, that is your waves and optics. We started unit 1. Last two classes we have been discussed format principle, and using format principle we have been proved laws of reflections. In this class, we are going to prove laws of refractions by using format principle. So let us start. First, we have to prove the first law of refraction by using format principle. Then we are going to prove second law of refraction by using format principle. Here first law states that the incident ray, the refracted ray and normal at the point of incidence are in one plane. Okay, consider this figure. Here the incident ray is your this one A to O, the refracted ray is your O to B, and the normal n dash at point of incidence O. These three has to present in one plane. That we are going to prove. For that, here I written some note. You can write in your note for your exam point of view. Consider a source is at A here. Okay, let us consider two rays AO and AO dash coming from the point AO, one ray, this one, and AO dash coming from the point A. Two rays are refracted from O and O dash point. O and O dash point. The corresponding refracted rays are O to B, this ray, and O dash to B, this ray. So it is refracted here. OB ray bends towards the normal. That means medium 2 refractive index is greater than that of the medium 1. Medium 1 is your rarer and medium 2 is your denser. So here refracted ray, that is your OB, bends towards the normal in dash. Okay, here we considered. Here O is the contact point of both 𝑓𝒔𝒄𝒕 plane, which is perpendicular to the medium 2, and medium 2 here O. This point is the contact point for both this plane and this medium. This plane �ＥFGH plane is perpendicular. This plane is perpendicular to this medium. Okay, same thing I have been written. O point is contact point of both. Here I have to write for contact point for both EFGH plane and medium 2. Medium 2 means this one. O dash considered as any arbitrary point on medium 2. Any arbitrary point. This is any arbitrary point. That means here O dash point one can consider here, can consider here, somewhere on medium 2, but not on this surface, not on this plane. Okay, you just imagine this path A O dash path obviously greater than that of the A O. Same thing it has been written. So if O dash is any arbitrary point on medium 2, obviously hence AO dash will be greater than that of the AO, and OB dash here, sorry, O dash to B, this path will be greater than that of the OB. Same thing it has been written. So total path, if I'm going to consider, then one path is your AOB, another path is your AO dash B. Here AO dash B nothing but AO dash O dash B, AO dash plus O dash B, and here AOB is nothing but AO plus OB. So if AO dash greater than that of the AO and O dash B greater than that of the OB, so obviously AO dash plus O dash B greater than that of the AO plus OB. Okay, now if here I written, if it will be considered that अगर इसको हम मान ले, अगर इसको ऐसे हम सोचें कि light travels by the path AO dash, this is dash AO dash B. If we are going to consider light travels AO dash B instead of AOB, that means light will travel a larger distance, right, which is contradicted with format principle. Same thing it has been written. If it will consider that light travels by the path AO-B, then it will contradict with Fermat principle, because according to Fermat principle, light has to travel from one point to another by shortest path. So the correct path will be what, or which one will be the acceptable path according to Fermat principle? The acceptable path or correct path should be path AOB. AOB. So if it is so, then O dash, whatever we consider any arbitrary point, will be somewhere on the surface of the medium. Actually, this O dash point has to coincide on this O point. Same thing it has been written, that is O dash point has to coincide on O. So here it has been proved what? Incident ray, here you can see incident ray AO, refracted ray OB, and normal N dash at the point of incidence O are in one plane. One plane means are in the plane EFGH. Hence it has been proved. Okay. Now we are going to go for second law. Second law of refraction. This law also called as the Snell's law. This law states that the ratio of sine I, here I is your incident angle, to sine r is a refracted angle, is equal to the refractive index of second medium with respect to first medium. That means sine I by sine r will be equal to refractive index of second medium mu2 by mu1, or it is written also as like this 1 mu2. It means mu2 by mu1. You just follow the figure to prove this law. Here consider AO is the AO and OB are the incident and refracted rays respectively. A to O, this point, O to this point. Okay, O to B are the incident and refracted rays, where N dash is the normal to the mirror, normal to the medium 2, here normal to the medium 2, or normal to the surface. Okay, normal to the medium 2 or surface. Just wait, I have to correct it. Okay, here normal to the medium 2 or surface. Here medium 2 having the refractive index is your mu2, and medium 1 refractive index is your mu1, and here we considered as medium 2 is the denser, that is your refractive index of medium 2 is greater than that of the mu1. Keep these things in your mind. So only for that, when this ray, incident ray, strikes on this surface, it bends towards this normal with lesser angle. This is your refracted angle, this is your incident angle. I is your incident and R is your refracted angles. From figure it can be found that the total path traveled by the ray is your A to O to B. That means T will be equal to mu1 AO plus mu2 OB, as we are dealing with two different mediums. So we have to write the optical path. The optical path is nothing but your refractive index times of the real path. Okay, so here this is the, if I'm going to consider the medium 2, the medium 2, inside the medium 2 the real path is your OB, but actually it is, if I'm going to consider the optical path, it will be mu2 refractive index times the path traveled inside the medium. So here OB into mu2. So total path, total optical path, if I'm going to write, it will correct. Okay, I'll correct it. Optical path, when I'll upload this load, I'll correct it. Okay, the total optical path traveled by the ray is mu1 AO plus mu2 OB. Now consider right angle triangles AHO and BCO. AHO, this one, this right angle triangle, and BC, this point is your C. Okay, this point is your C. CO, that means this triangle. So this is your 90 degree and this is your 90 degree. So if this angle is your I, so obviously this angle will be I, because as this is your 90 degree, so this angle is your 90 minus I, so obviously this angle will be I. Already we have been discussed. Likewise, this angle R means this angle also will be R. Now consider AHO. AHO triangle, that means this triangle AO, A to O distance, AO distance, A to O distance will be AH square plus HO square root over, according to Pythagoras theorem. AH square, yes, AH square plus HO square, right? Then OB, considering BCO triangle, this triangle B, sorry, O to B will be equal to how much? BC square, B to C, B to C square plus OC square. Here in this figure we considered from H to C the length is your A. If this length we are going to consider X, so obviously this length O to C is your A minus X. So T will be equal to total optical path traveled by the ray is your mu1 into AO. AO, instead of AO I written this much, instead of OB I written this much. AH, instead of AH here I written H square, because A to H distance I considered H, and B to C I considered this distance, this much distance I considered as L. Okay, and as I told, if this H to C distance A, then H to O distance is your X. So instead of AH written as H, HO is your X. Instead of BC, instead of B to C is your L. So obviously OC will be A minus X square. Ladies, this is your equation number 1. Now we are going to apply the Fermat principle on this equation number 1. According to Fermat principle, light has to travel from one point to another by shortest path. That means T is the minimum or least. Therefore, derivative with respect to X will be equal to 0. D by dx of t should be 0. So d by dx of t value here I substituted, and you just follow these simple steps. You can get, here you can see derivative of this one, mu1 is constant, derivative of this one is your 1 by 2 root over of same, and x square derivative is your 2x. Likewise derivative of this one written over here. Here 2 got cancelled, 2 got cancelled, this negative term taken this side. Okay, this step. In this step here we get mu1 x by h square plus x square. Here 2 got cancelled, mu2 a minus x, this much, right? Then same thing again I written. Okay, here. Okay, now we are going to consider the right angle triangles here, A, HO and BCO. So if I am going to consider this value, what mathematically what we can write, or trigonometrically what we can write? Trigonometrically x by h square plus x square. Just consider AHO triangle. AHO triangle, x here, this is the x, and this diagonal value is nothing but h square plus x square, and this angle is I. That means this value can be written as sin I. Simple. So if I am going to consider this one, a minus x by a minus x square plus l square root over, and I am going to search whatever the trigonometric function for this value in this figure. This is your R, this is the right angle triangle, this is the 90 degree. So a minus x means this one, this means this is your height, and this is the diagonal, this one. A minus x square plus l square is nothing but this diagonal OB. Okay, that means this is nothing but your sin R. Very simple. So here x by h square plus x square is written as sin I. A minus x by a minus x square plus a square root over written as sin R. That implies sin I by sin R equal to mu2 by mu1. Hence proved whatever we intend to prove. This is your second law, or called as Snell's law. Okay, so here up to this class we have been completed format principle, reflection and refraction at plane interface. That means we proved the first and second law for both reflection and refraction by using format principle with in detailed note. I'll upload the note. You just download the note and watch the video and prepare directly for your exam. I suggest no need to write the note again. You can take the printout of this note itself. Okay. Next class we are going to discuss matrix formulation of geometrical optics. So thank you so much for watching this video. Thank you.